All right, well, it is 3 o'clock. I'm sure some more people will come on in, but we will go ahead and get started. So thanks so much for joining us today. This is our 11th webinar. My name is Jen Paffenroth. I am the Business Support Manager at IEC Thermo. If this is your first time joining one of our webinars, welcome, and be sure to subscribe to our YouTube channel, IEC Thermo, where you can find lots of other good hemp-related content. Everything from hemp drying basics to genetics to a panel of hemp farmers who shared what they learned in 2019. Today we have some very special guests and industry experts from FarmMax joining us, and IEC Thermo is also glad to call them a strategic partner. We have Beth and Ty Stukenholtz from FarmMax here today. Ty is an agricultural engineer and the CEO of FarmMax, and Ty and his brother Jay have about 23 years of experience creating specialized harvesting equipment for combines, which you will hear all about today. We also have Beth Stukenholtz joining us, and Beth is a biologist and earth scientist, and she has worked in biomass fuels and other biomass applications for 20 years. And then we also have Matthew Clark, who you may or may not have seen on our webinars before. Matthew is the CEO of Think Happy Consulting, as well as the Director of Safety and Compliance here at IEC Thermo. So in just a moment, I will hand it over to them, but one thing you should note that we will be taking questions at the end of today's webinar. So feel free to type in any questions you have in the Q&A section at the bottom of your Zoom screen, and we will make sure to get them answered at the end. So welcome everybody, and Ty, Beth, Matthew, thank you for joining us. I will turn it over to you guys now.
Well, thanks, Jen. We appreciate IEC Thermo inviting us to participate in this webinar. And like Jen said, we're FarmMax is the three of us. It's Ty and his twin brother Jay, who are both agricultural engineers and graduates of the University of Nebraska at Lincoln. And I am a biologist and a graduate of Eastern Illinois University. And we have created the Interceptor, which is an interesting piece of harvesting equipment that attaches retrofits to John Deere S-Series combines and collects the seed, the flour, and the fiber. It separates those three parts of the hemp plant and processes them so that they can be sent to drying.
We thank you guys for inviting us to participate in this. A little bit of background and why we're here today. My brother and I, we started looking for ways basically where we could come back to the farm, because in agriculture it's hard to get back into this industry, you know, as a small entity, and we needed a way to make extra revenue at the farm. And that's where we got our start. We learned of the value for corn cobs, which we were corn and soybean farmers at that time. And this is back in 1997, and we needed a way to make more revenue with our farm. So we started out and we built an entire combine from scratch. And that was in 1997, and we made a different machine almost every year for the first, 10 years per se. And by 1999, the machine that we made from scratch is on the bottom right corner. It's the black and white machine here in the picture. And that was a corn cob harvesting machine that we created. And at that time, we started to design or figure out how to take the technology, the cleaning the corn cobs out in the field, and translate it into more of a conventional combine that a farmer would be running, harvesting corn in the Midwest. And that's where you see a lot of these other pictures of the machinery that we developed in the various stages. You know, this bottom picture here of the John Deere pulling the wagon, that's clear back 20 years ago that we did that. So a lot of these pictures, I think the yellow one here is on the bottom is probably 2002, and we get into later 2000s. And then along the way, we've met a lot of different people looking to take our technology and use it for different uses. And we worked with a wildflower farmer that grows native grasses and wildflowers along with corn and soybeans in this operation. And that's this top picture here of the New Holland. We designed a machine for him specifically for his application, and we've probably harvested over 300 types of specialty crops with the combine at this point, working with him. So, you know, working with him has been it's been a challenging endeavor in some ways, because he does stuff that you would never even think about processing with the combine. Some of the wildflowers that he harvests that we've been in have been extraordinarily wet. Some of them rat far worse than hemp does. So when we hear farmers talking about what you can't do and can't do with hemp, we've kind of been there, done that, experienced it already. And, you know, there's always new experiences that come your way when you're inventing stuff, and a farmer's going to take a piece of machinery out there and try it in a crop that you never saw coming. And that's kind of what we've experienced is, you know, all these years, you know, working with all these different crops and, you know, trying to collect things that we would be throwing out. And that's what a combine, you know, combines are designed to solve the issue of harvesting the grain. Well, what we do is we take the combine and we make it not only harvest the grain, but we also try to collect a byproduct that it was going out on the ground. And we'll get into this, you know, as we get into our presentation, but for hemp, you know, that's the flower. So while we're harvesting hemp, the combine is sorting the grain out, and then we're collecting the flower on the back end. And we've taken the last 5 years to basically look at, you know, what's the best method to do this. So the technology that we're showing you today didn't evolve, you know, overnight. You know, we've been slowly trying to make this, you know, work the last 5 years exclusively for hemp. And some of these equipment, you know, we've been working on for the last 20 some years. So one of the interesting pictures right here in the center, you'll not only see the red combine harvesting corn, but this bottom tank here is the grain, and the biomass is in the top tank. So we've got a dual commodity cart, you know, taking both a grain and a biomass from the field. So, and you can see here on the right, just above it here, you can see that's this wagon here loading into a 13'6", 53-foot van trailer out of the field. So, you know, these are all things that we've developed through the years, and this is probably 1/3 of the machinery that we've done in the last 20 some years. So, as a lot of people know, hemp is a very challenging crop, and one of the, you know, things that is challenging is basically some of the harvesting criteria with the THCs, you know, that we're dealing with, and the window that we have to get that done. You know, if we let it out in the field and it gets too dry and we're harvesting the trichomes and the flowers, you know, we'll start to, as the seed matures, some of that will get lost. It'll drop right off the plant. Windstorm comes through, and, you know, suddenly what you had was 100% out there, and suddenly it's 40% out there, 50%. So we got to get out there in a timely manner. And then the other side of it that goes along with the physiology of it, if we leave it out there too long and it gets hot, and the government comes in and says we have to destroy it, that's a disaster, and that is our worst case scenario. Getting into the, like the hemp maturity that we just said, you know, some of these maturities are all over the map, and as the plant dries, the seed is at different states of maturity. So we're trying to maximize that for seed. We're trying to maximize that for CBD content. And one of the things that, you know, most people are doing in this industry for CBD content, and there's some very good reasons, is harvesting for CBD wet. So when we do it wet, we need to dry it. And if we're harvesting it with a machine like what we're creating, you know, you've got to have a system to dry it. And if you don't go to the field, if you don't take this to the, if you don't go to the field and have a plan, you know, you're going to have material losses that you won't, you know, rebound from. So you've got to have a good plan going into this. Trichome losses. This is an interesting plant as it dries. The trichome is very sticky, and as it dries, it tends to, it doesn't really lose its stickiness, but it does change some. But what you'll see when you're seeing some of our pictures is it's a plant that you have to be, you have to have a plan for how you're going to deal with it. If you plan on just, running this through a machine and not really care what, how it's being handled, what happens is you run it through an auger and on a machine, and suddenly, you get a little bit less loss, a little bit less CBD content. You run it through a mechanically, system, and you keep managing it and letting it kind of be, handled harshly. At the end, you have a very low quality product. So, that's our approach here. Is we want the farmer to harvest a very high quality, product, and there's always losses. Fiber wrapping is something that we deal with mechanically, and there's different times. With wet, we don't see the fiber wrapping so much, but it's always something that we keep in mind. And when we design our machinery, it's been very helpful to come from the wildflower and native grass harvesting, and take what we learned from there and use it for our equipment. Even handling cobs. A corn cob is not the easiest material to handle, when we're blowing it into a tank. So
this is one of the myths that we would like to dispel finally. And we've heard this repeatedly about threshing, that you shouldn't thresh. And what people don't seem to understand, and what we understand as farmers, is threshing by definition is the process of taking the grain and removing it from the chaff that it's attached to. And threshing was done by hand, which is what the hemp industry has been doing, is threshing by hand. And any mechanized process that separates the grain is threshing. So when we hear people using these words like separating, bucking, stripping, sizing, it's called a lot of things, and people like to use their other buzzwords about it. But at the end of the day, it's threshing. And our goal that we set out with this machinery was that we would thresh just once, utilizing the combine the way it was designed to thresh, to protect and capture those trichomes with the CBD and terpenes, and then utilize preservation technology like drying to stabilize and preserve that product in the most optimal form that you can get it in right out of the field. So this is, and you can see by the red combine in the picture that what we do in the field is we capture the dust, where a lot of that trichome material is going to be lost if you let that dust fly. That's why we have the system that we have that utilizes air instead of pushing the material through the combine. And so we can capture that valuable dust that would otherwise end up stuck to your machinery and stuck to the inside of the machinery. And you're not losing those valuable trichomes.
So we thought we'd get into a little bit on how a combine works. For a lot of people, this is probably redundant, but we also can kind of explain a little bit how our equipment works. And, we'll get this running here. So on a John Deere S series, which is what we've modeled, we basically have the crop coming in the front, and we'll get into the headers that we use later in the presentation. But what we have is we've got the material coming in the front, and basically as it's in the rotor here, it's getting this rotor. You can set the speed of it and change it. And this is what typically a farmer would be running, let's say if they were harvesting hemp for seed. So we've got the material in here, and as these threshing segments pass over the concave, this concave is a screen. So what we have is the threshing. We're rubbing the material and we're getting it sized so it passes through this grate into the cleaning chute here. So by changing the speed and changing the distance on the concave, we have different ways we can set it. We can also change these elements all come out, and we can put in different sizes, and we're still experimenting, and we're learning a lot here as we go, because this is our first year with hemp. I'm not sure that you know, last year we ran all this setup was just a corn and soybean combine. We're looking at, you know, what does a small grain combine do for like wheat? All things that we not necessarily know, but we know that there's possibilities. And that's one thing that a combine really gives over other methods of harvesting is it already, you know, like I said, we've used a combine to harvest, you know, 300 different types of crops. So, you know, adding hemp to the, yeah, and some of them have smaller seeds than hemp. They look more like salt and pepper, some of the crops that we've harvested. So you want to talk about, you know, pricey crops. We've had some of the seed crops that we've helped harvest are like, I believe we've gotten up to $1,300 an ounce. So more expensive than gold. So, you know, we have different things we can change here, but basically as we're harvesting through the field, the flowers, the grain gets fed down into this, with the flowers gets fed into this area down here in the middle where there's sieves, and this fan produces air, and there's a sieve here. So as it oscillates back and forth, the grain gets put up into the grain tank. Yep. And the flour material is blown out. Now, if you don't run enough air, you'll end up with flour material up here in the grain tank. So the ideal situation is get your air to where it blows the flowers out and the grain goes up into the grain tank. And there are some farmers, many farmers actually have used this technology to basically open up this sieve, and they run the flowers and the seed all together up into the grain tank. And I see that a lot in Oregon. We've talked with people in Colorado that have done it, you know. So there's people using a combine to harvest the flour and the seed together, you know, a lot of parts of the country. The problem that they run into, so the combine threshes the grain and gets the flowers down here in the receiving area, but you start down here, all this material ends up getting run through an auger, and the auger, basically, it's not shown in this picture, but it gets fed up through a clean grain elevator. So you've got material getting handled with an auger, and then you have a fast-moving elevator chain that's going straight up, and then into the grain tank. We've got usually a 5 or 6 foot auger, and every time you move material with an auger, and if the machine's not full, what you get is the auger kind of pinches the material up against the outside perimeter of the tubing. So what happens is it pinches, it wipes that oil off that we're desperately trying to take to market and save. And then if you take a typical combine like this, and then you want to unload it, the other problem that we run into is the augers in the grain tank. There's mobile augers to help clean the grain tank out. So what happens is this flour material is light and fluffy. It will not feed down into the auger troughs. So what farmers end up doing is they run the auger and they drive alongside of it with a truck or wagon, and this auger will feed into it 100% of the time. When it's 100% of the time, the auger's empty. And instead of being full, and if it was full, it would be flour on flour. But if it's empty, you know, this auger is meant to unload this grain tank, you know, in a couple minutes at the most. It's not meant to run alongside the machine while we're out in the field. So what we end up with is basically a flour that all the oils that we want are rubbed off. So what we end up with is a flour that has, you know, lost its value for CBD production. And that's what we're, you know, trying to help here is, you know, make a combine efficient for CBD harvesting. And that's been our goal in our project, because when our material basically gets rubbed off, it's airborne until it gets to the wagon. And we'll get to show you a little bit of that. But this happens to be the models that we're setting up to do. And we'll get into the next slide here, however we can. Okay, we've been there before. We have to back out somehow. Okay. Well, it's interesting to get into all the mechanized parts of a combine. So And we sure thank John Deere for putting this up for us so we could show everybody how a combine works. The last time we...
I had trouble with this before.
Yeah. There we go. So now we're going to get into a little bit, the interceptor and just some basics and how it works. We just saw the internals of the combine. And so we've got our grain in the tank. We've got the flour separate the stems. One thing I didn't mention is if you cut off the stem is so long it won't pass through the grate of the combine. So the stem, which is the, for fiber uses, it gets run through the combine and back out on the ground. So we've got 3 product flows. We've got the seed in the tank. We've got the biggest stems are going back out onto the field. And what we're seeing down with the grain is some of the smallest branches will get pushed through that small grate along with the flowers. And what our equipment does is it basically keeps that flour material, because we're got air going through it, it keeps it suspended. So it's really not coming into any mechanical devices until we get to the interceptor. And what the interceptor does is it provides a little bit of suction in the back, and basically the flowers get passed into this air chute and it gets blown into the wagon. And the air chute here, unlike if you've seen like a forage shopper harvesting hemp, a forage shopper has a big swooping gradual spout. You'll see a lot of them on YouTube out trying to harvest flour. And what our system does different is the forage shopper harvests the whole plant and chops it into bits, but they might have a stripper head and they might be still running it through the chopper and blowing it to a wagon alongside. But they've got that big spout and they're letting the air, basically, they're letting a vulnerable product with a very fine, the trichomes, they can be blown away with the wind. So what we do is we have a completely enclosed air chute, and this air chute is attached to the wagon that we pull. And so when you turn a corner or if you go through a ditch, it doesn't matter. The chute is always making contact with the wagon. And one of the things we do, you can see our drawbar here that is hooked behind where we hook our wagon. It is directly below the pivot point where the chute goes. So by doing that, we're minimizing how this chute moves. We're trying to, it's also, helps because when we're going through a field like in southeast Nebraska where we farm, this chute is very busy. I mean, it is turning, it is pivoting, it is extending, it is going all over the place. And if you just had like a stationary unit out here, what you'd have is when let's say you just had a rigid spout, you turn a corner, you're missing the wagon, your product's going on the ground. You go through a ditch, suddenly you're missing the spout. And that's, one of the critical things. And how we get by with this machine we'll go to the next slide, and why it works in wet material is something we learned from corncob harvesting and wildflower harvesting when we're dealing with wet products. Basically, we have all the chaff entering this beater, and this beater is force-fed by a blower. And this blower doesn't come in contact with the material. Basically, what it is doing is supplying air pressure, because if we're just mechanically trying to throw the flour and it's wet, what happens is the momentum of it gets basically up into this area. It loses its momentum because it's came into contact with too many surfaces, and it just plugs up. So by putting air in front of it, we can turn the air up and we can push wetter material through this air chute into the wagon. So that's very, very critical, and this is a patented piece of equipment that we've designed. One of the things that you'll notice here is this is actually what mounts to the combine. And to make it so we can attach it, a combine can be anywhere from $80,000 to $550,000. we don't want to cut on the machine. So what we have here is an attachment that we can take on and off. So if a farmer has corn or soybeans, wheat, he's using the combine for another crop, he doesn't need this, we can take it off. We've got hydraulics, we've got a patent pending system how we take this on and off. So you can take it off, in minutes rather than a day of lost service out in the field. And we've, at one point in the previous years, what we'd have to do is we'd have this sitting stationary on the ground, and we'd have one person guiding the combine as we backed up over it, and we would latch it on. This last year, we made a really good development for putting this on the machine. We have our own hydraulics, and you can roll it up. If anybody's ever moved a pallet on a pallet jack, we put our equipment on basically in the same way. So it's been a great method to take this on and off, because even the machine we ran last year, it was rented. So we couldn't, we don't want to modify, nobody wants us to cut on a combine. We go through great lengths to make sure this bolts on in a way that a farmer can not worry about his investment. Well, here's a picture of the Interceptor. One of the things you'll notice is there's a sensor right here. What we're doing, and this is going to be new this year, first year we've run it, we're actually measuring the flow of material as it goes into the wagon. So I believe we're probably the first ones in the hemp industry to actually try to actually have an in-cab monitor that says what the output per acre is on the fly as we're going through the field. So ultimately, we hope to get to where, it'll say the bushels, how much the grain is yielding per acre, and we'll also have a flour as a pounds per acre as the yield. So, it's a technology that we're developing. And
Sorry, dogs.
we also have a monitor that tells us, because this is in the back of the machine, if something goes wrong with our equipment, you cannot just keep driving the combine. You have to stop and figure out what's wrong. So what we have been working with, and this is also new this year, is we have an in-cab monitor that alarms the operator if something stops. It tells them the speeds of everything that's turning, along with when the wagon's full. It also says the pounds, per acre ultimately as you're going through the field. And that's we're real pleased that we've been able to put a system together that tells the operator what's going on back here, because it's not like you can see any of this. So it's very important that an operator knows when to stop. And here you can see a little bit more. We pivot here as we're going through the field. We've got another hinge point here. You can kind of see the rubber seal back here that we're still really developing. When we get into the drier hemp, there is a lot of trichomes floating around. And I wouldn't say that we are collecting 100% of the dry hemp. We still have a lot of work to do. When we're doing the wet flour material, it's very successful. There really is no dust anywhere. You can't even hardly tell that we're harvesting. And that's one of the important things for working with a dryer company. There is a lot of advantages to dealing with wet material versus dry, because the dry material, we deal with losses that are overcomable if we harvest it a little bit wetter and we can dry it. And one of the things that we deal with is, we can do a lot of acres in an hour, and you've got to have a system that can handle that. So this is the material that our system harvests. You can see the bottom right here. This is the seed in the grain tank. If you don't turn your air speed up and set the combine properly, you will get some of this flour material in with the grain. But if you turn your air speeds up, what you'll end up with is these three products. You get the grain in the tank. This is this is actually cherry wine variety, or X59. I think it was cherry wine. And this is what the combine leaves out on the ground. So if you take a different harvesting approach, and let's say you're planting the grain thick per acre and it gets tall and stemmy, and you'll more than likely be using the combine to cut higher off the ground, and you won't be running like a 5 or 6 foot tall plant through the machine. You'll be taking more of the top 18 inches. So the plant won't look like a shrubbery tree like this that has its limbs brushed off. It'll be more of a smaller, shorter piece with smaller branches. And this is the flour material. You can see a few immature seeds that end up in the wagon. That's because they haven't matured yet and they're not developed yet. This was probably done at 70, 75% moisture. And this is a product that you just cannot let sit for very long before it goes bad. So you have to have a plan when you harvest this, and you can do, let's say our machine can do 10 acres an hour. You don't want to get too ahead of yourself and harvest too much. You want to make sure that you've got a plan to get it dried. And you can see one of the things that we talk about threshing. Well, when we look at what we're doing with the rotor is breaking up the flowers, but the trichomes are still there. The oil is still largely there. And we're still trying to figure out where we're at as far as CBD content. We're just basically did some of our first tests here this week to see how good our approach is on dry crops. Unfortunately, as far as figuring out where we're at for CBD for wet content, we'll have to learn a lot of that this next fall as we get our machine out there and do some more testing. Getting into a little bit, one of the farmers, the wildflower farmer that we work with says, I like to have options. And we've run into, he's used all 4 of these methods for harvesting wildflowers. We've got a shell-borne draper head, which there seems to be a lot of people trying to use that in hemp. And it has some possibilities. It also presents some challenges because it strips off the plant. And if the machine gets, the machine, these rotary combines, they can take a lot of throughput. And if we don't get enough material in the rotor, we're going to see rotor losses. So it's something that we're going to have to present, or we're going to have to meet the challenge if somebody wants to run a shell-borne head and strip hemp off. It'll be a little bit different than cutting this bottom left picture with the draper head, which is what we use, where we're running a lot more material through the combine. And the combine likes to have material in it to process. One of the cheapest and most economical heads that you can run is an auger head, which is typically what we use here in the Midwest, or we at least used to. But what we find is it basically, as the flour material gets fed over these flutes, what we end up with is losses with hemp. So we don't really recommend anybody to use that for harvesting CBD, especially. For grain, they can use that, and they just have to accept their losses. And one of the things that we've been talking with some growers about is using a pickup head and swathing it early and letting it dry. And there's some possibilities here. It also presents some challenges because if you let hemp dry out in the field, we know we can capture a lot of the trichomes with our equipment, but it's just simply not going to be as effective as using a draper head and cutting it wetter. Because the draper head, we can harvest a wetter product, where we're up here. The other challenge we have is, this concept may work in Colorado, but in Nebraska and in Illinois and in Iowa and in a lot of these parts of the country, if you swath this, your whole crop is at risk. And if you get a rain, it can be a total loss. So, this is a market that is probably very region specific, where we feel like the draper head and maybe the stripper head are probably better suited for what we do in the field. So a little video here of our machine harvesting in Kansas. This was a cherry wine variety that was transplanted, and this was their first year. Yeah, this was their first year growing, so the stands weren't very big. It was planted late. It had a lot going against it, but our machine worked. I mean, it did exactly what we wanted it to do. You can see early on in this picture, there is some flour material in the grain tank, and that's because we didn't have the fan speed turned up on the combine, because right out of the box, we had to learn how to set the machine because we'd never done that before. So by the time we got to the end of it and we had our fan speed almost on the combine set twice as fast as what we began with, and we had an incredible sample. Even going through weeds, we were able to get a very clean grain sample. And there's some crops, it's interesting, This was supposed to be a feminized variety, and it was full of seed. And there's a lot of growers that ran into that, and that's one of the things that we'll see more. The wagon is actually remote control, so the tractor operator can dump it. So that's nice, because the operator in the camera, or operator in the cab, just has cameras, but the operator in the tractor can dump the wagon, or the operator in the cab. So that was a first for us too, remote controls. So you can see the draper head as it's running the field. It just kind of tumbles it like tumbleweeds. It's very gentle on the product, and it's very even flowing. And when it cuts it off at the ground, it cuts it off so close to the ground that you hardly can tell what was even planted there. Yep, you can see in this picture what we're blowing into the wagon. This is the flour material. And you can see that we put it in there with very high velocities. And we didn't even, when we're doing wet, we didn't even need to enclose this, because there just wasn't much dust. When we get into the dry crops, this all has to be very tight, because the trichomes are so fine, and we're putting air back here. And what our technology does is how we keep the trichomes, and why it has the possibilities of working in dry material, is because how that wagon is covered. I mentioned the hydraulics and how this comes on and off. You can see there's a little wheel back here, which you saw in the video. We basically have hydraulic components so we can take that on and off. And getting into how we vent the air out of our wagon, we just use a fine mesh, so the material stays in and the air gets vented out. And that's something that was, we've been doing for a lot of years, but with hemp, with trying to collect the fines, I would say that we have, certainly more to learn, and we have a lot to learn in hemp in general. What we're finding is farmers are all over the map with what they're doing, what they're growing, the varieties. We've got everybody from planting, several thousand acres and wanting to use our equipment with the green crop dry, to somebody that's doing a variety that has huge stems at the ground and wondering, what we can do to cut that off and run it through the combine. And, we're trying to, best address everything we run into, but there's always going to be a situation that's going to present challenges. We've been doing this long enough that we know that, as soon as we make plans, we have to change. But, that's one of the things that we've really been, good at, is trying to work with farmers and solve their problems. And we certainly don't want to create any new ones. But that's one reason why we're here talking today with IEC Thermo, is we're creating a huge problem here, because we're creating a lot of wet biomass that has to be handled, in a very effective way. Because if you're out there and you're doing this and you've got rotten material or you've got poor material, the processors are going to be looking at the farmers that are doing this the right way, and they're just going to reject the ones that have a low quality product. So I'm not sure. I think we're getting down to our last couple slides, and want to take Matthew in here to talk about some of this stuff. You can talk here, Matthew, anytime. I'm already getting tired of visiting.
Well, sure, Todd. No, thank you. I mean, your presentation's been great, and I think you guys really touch on a lot of the pain points within the industry, and I've done a really great job with the Interceptor in trying to address a lot of those in a really effective way. I mean, I think that's what's exciting about, what you and your brother bring with your past agriculture engineering experience, and having worked with all these different specialty crops, really being able to apply that to solving this problem. And so we certainly, at IEC with our dryers, see a lot of the same kind of issues, right? And part of the reason that we are developing these kind of strategic partnerships is because, you really hit the nail on the head. For your equipment to really have the value it needs, you need to effectively be able to dry at the same kind of capacity. And same kind of thing, for folks to be really happy with the dryer and how it works, they're going to need to be able to bring that capacity to the dryer, consistently. And so, like you talked about, there's a lot of growing up to do still to try to match these different areas. But we've certainly learned that in order for our equipment to succeed, we have to kind of have an awareness of the entire supply chain and really encourage people to kind of work backwards from what they are going to try to produce as an end product and think about how they're going to get there. And one thing we really learned last year is that, obviously, as you touched on, threshing or bucking or whatever by hand is just not effective. The labor costs are just way too high and doesn't produce enough material to really make the large capacity drying systems work at the efficiencies that they're really meant to. And so what I love about, this kind of equipment, it's kind of taking those lessons from last year and applying them in a way where, why not do a lot of that, sorting right there in the field. So, and that was something that I think people talked a little bit about last year, but as we've seen different types of harvesting take place at scale using different things like forage choppers and modified combines, what we really found out is that, especially for the dryers, if you don't want to be spending time drying it, then you shouldn't leave it in there. And so seeing a piece of equipment like you guys have now that really allows you to sort that out in the field with that mindfulness of maintaining all the trichomes, because that's another problem we've seen, right? With what we see called dust throughout the industry, really can be the money there, right? So understanding that, we always preach wet harvest, and that it's, from my experience with the plant, it's always going to be the time you experience the least amount of loss. Because like you said, no matter, as soon as it starts to dry out at all, it's going to become more brittle. The trichomes are going to break up a lot more easier. And so, that's why having a system where you can kind of do a lot of that work in the field, then bring it to a dryer like ours where you can have that continuous flow capacity and have it already, sort of pre-sorted. The flour material that you showed is really great for creating the kind of consistent feed that makes our system thrive. One of the things we learned from last year, as you kind of talked about some of the challenging natures of the plant, is that, taking the material as it comes from the field and really kind of fluffing it up through a secondary grind as it goes into the system makes that extra step too. So for me to look at material, potentially coming out of a harvest through a piece of equipment like yours already being sorted out, it makes the rest of the process just work so much better, and saves everybody so much more time and effort. And that's one thing I'm sure you guys know from agriculture, and something I learned even from the adult side use of cannabis before coming to hemp. It ultimately comes down to your cost of production. And for, whether it's a small scale or a very large scale, anything you can do to kind of automate those things just becomes really crucial. So it's exciting to see, folks in different spaces all kind of working together to try to solve those problems at the kind of scale that we're dealing with, right? I mean, if you can successfully bring down and sort 10 acres of material an hour, that's probably, you're looking at wanting to run one of our 6,000 or 15,000 models just to keep up with that machine. And that's, 10, somewhere between 6,000 and 15,000 wet green pounds of material coming in there. So that's what we've really seen, is people are learning a lot from last year and being able to apply those lessons to how we can make all these different pieces of equipment work together.
Yeah, we're learning, with this industry too, and we've, enjoyed talking with, meeting some new people that are more involved with, what's happening with the hemp industry and what's coming. And, one of the biggest issues that we see coming is in October, when the federal regulation takes over the state level, and this harvest window of, in some states, they're not worried about, like Illinois, they're not worried about their product getting hot. But in other states, like Nebraska, if, we've had one farmer in Nebraska, it's been challenging for us because there was only 9 permits actually last year granted for harvesting hemp in Nebraska. So to test our equipment, we had to line up, going out of state, and we had to work with a grower that, was willing to try something new. And we're fortunate that, a lot of a lot of people in the hemp industry are innovative and are willing to try new things. But then we have the other side of the hemp industry that thinks we have to, the hand harvesting is where it's at, and there's no, if you're doing anything but hand harvesting, you're not following what you need to be doing. So,
Right.
but the hemp, getting back to it getting hot, and I mentioned the nine growers in Nebraska. One of the growers here put in for a 2-week extension to harvest their hemp later because they saw their CBD level was getting a little bit higher to where they wanted it. And what happened was the THC went up too, and it got destroyed. And yeah, it wasn't even a small, it wasn't even a big farm at all, and it still got destroyed in a total loss. So if you don't have a plan to, take this out in a timely manner, and, we can go out there with the combine and take a machine and, we felt sorry for, when we were harvesting, we were, in the same field with people hand harvesting, and we went out there and harvested for a few minutes and did what they took, a week to do. So,
well, yeah, and that's, I think, we run into a lot of those folks that have had that experience with hand harvesting where they get an acre or two into it and realize that they're running out of space, that the rain's coming, it's starting to mold, and it's all ripe at the same time. And so you really touched on the importance of being able to take it down and get it stabilized to kind of lock in that maximum potency for CBD, retain as much terpenes as you're going to be able to. And then also you kind of touched on, just coming to a realistic terms with what the scale of this means. And that means, things like hand harvesting and hang drying are just kind of not practical for what we're trying to do. If you're trying to create a smokable hemp flower product, then sure, you're going to put that time in. But for what we're talking about, taking down, hundreds and thousands of acres, and stabilizing that effectively without having loss after you put all that effort into taking it down, you have to let go of that, sort of notion and realize that, I think maybe you touched on it in your HIA presentation, the extractors are literally going to grind this stuff up, So why you're spending a bunch of time worrying about it going through a combine, I don't know. It's just sort of understanding that's how it's going to be extracted. Eventually somebody's going to do that anyway. So why not do it earlier in the process and then look at different ways, as you said, out of your machine, you're getting good flour, there's seed, and, I think people will realize over time that they genetically and things, focusing on just one portion of the plant probably isn't a great idea. So when you have a piece of equipment that can easily sort these things out, suddenly seed isn't that big of a problem for you. Having some male, dealing with the issues, you don't have to pay for feminized seeds anymore. There's going to be a whole supply stream for that, and then the fiber, and then there's still hurt and things that could be collected from the flower. So there's just it just takes those early steps and things that are going to happen later in the process anyway, and just allows you to really be more effective and just more thoughtful about how that supply stream is going to work.
And I think even, when it comes to when they're processing, and it goes also trickles down to drying, what we're doing is we're trying to just supply the flower with no stem in it, or very minimal stems in it. So, if you take a product that has seed in it and stems, you're either going to have to probably sort that out. And if you do take it to a processor, the processes the stems in with it, the CBD quality is probably not going to be there, and they're not going to compete with somebody that has a, high quality, flower only product. And drying too, why spend the money to dry the seed in the stem? So,
well, exactly. And that's something we, a lot of folks learned last year, I think. And that's, something to consider when you're looking at baling, because, balers do chop up that stem in there. And then if you're drying bales later, you're definitely using some of your drying capacity to dry stem that, depending on what you might do later, may or may not be something you want to do. So those are really good considerations because
I think, for
why
sure
dry something you don't need to dry?
I think for sure you can say that, we shouldn't probably be giving the same, value to the fiber as the flower, at least at this point. So,
Yeah, no, we're definitely in the early days. And I think, but that's sort of the goal right now, is to produce the best quality extract material. And to do that, it's, getting rid of those byproducts that don't add anything to this, to the extract. So, leaving those stems in the field and just focusing on getting that out of there is really important. And I definitely heard a lot of stories last year of folks having material rejected by extractors because it just, didn't meet their standards. And a lot of that was, it was stems and seeds and other contaminants, really that didn't do any good. So that's another good point in that. Right now the game is creating CBD extract, and we'll see other things develop from that. But the best way to create the best extract material is to not include anything in it that, the extractors don't want. And that's just another way that you can maximize your drying capacity by not spending time drying that stuff that extractors don't want. So yeah, definitely important, because like I said, it really goes back to that sort of cost of production. Another thing I really liked about some of the things you've added this year that I think, sort of looking forward at the industry, is your ability to track what's coming through your equipment. And so what's going into that wagon, we really think that, and I know from my experience on adult use cannabis, that the track and trace technologies that are out there are going to really become part of the industry. Knowing that we're looking at, FDA type approved products, having that chain of custody that can all go all the way back to production, I think is going to kind of become standard. So being able to plug in those different kinds of data points into these kinds of programs, it's especially where, that material coming through that wagon, it has a certificate from a lab associated with it that's what makes it legal. So knowing that acreage is associated with that material, these are all important part of the puzzles that are still developing, but I really think, kind of put you ahead of the curve and seeing what's coming in the industry.
Yeah, it's all, when we're all doing this, new, it definitely is a challenging, it's exciting and it's challenging all at the same time. So trying to meet the needs of everybody we talk to is, there's some conditions that are just difficult to work with. We can't be the answer for everybody, but we're going to do the best we can. So.
Right. Well, that's it. I think there's a lack of standards. There's such a, you touched on the lack of, the diversity in what you see in terms of genetics and material and, so much variation. So we definitely have a lot of work to do, but it is exciting and, like you said, fun to be part of coming up with these solutions and working with folks to be able to provide that information to help them succeed better in the future. So we are, we always say here at IC, we want to be good stewards of the industry. And for us, that's helping folks find these kinds of pieces of equipment that are going to not only make our dryer run better, but are going to help make this more predictable for farmers, make it a more regular commodity that, as you sort of touched on, I think being able to rotate through crops and, have it be something that helps farmers out. Certainly not the gold rush that some hoped it might have been, but it's a plant that's going to, I think, be used in a lot of products eventually and has a renewability that is great for everybody. So.
Yeah, definitely. And Matthew and Ty, I'm gonna cut you guys off. It's getting close to 4 o'clock, so we're gonna get to some of these questions that we have here. If that sounds good with you guys. So if anybody does have a question, this is a great time to put it in the Q&A section. We'll go ahead with the first one from Laverne. He asks, Ty, what is the average gradation or size of the floral biomass when harvested at 60 to 70% moisture?
Size of the material. And as far as size, I would say it's probably, it largely depends on how you set your combine. So it's really kind of hard to tell you an average size, but you'll see some dust in there and you'll see something in, you know, an 1/8 inch in diameter, or maybe a 1/4 inch in diameter. So, you know, it's sized pretty small. I mean, the flower generally is not intact, but it's intact in the way that it counts, we believe, that the oil is still with the flower particle. So, you know, you're basically just taking a bud, and you're not necessarily like smearing it, you're just breaking it up. So I guess that's the size of it. So, you know, the size was, yeah, we're not crushing it, we're just kind of knocking it apart, I guess you would say. So, you know, there always is some, you know, loss, but, you know, one of the things that we really want to try to do when we're using a combine is get as much material on material instead of material on steel. And by doing, you know, that, you know, we're going to get a more uniform product that's higher quality. So, but I would say anywhere 1/8 inch to 1/4 inch, you know, in size probably catches pretty much, you know, the area that we're shooting through on the combine is probably, I'd say it's probably 1 inch by 2 inches maybe in size. So as far as what we're sizing through on, and that varies with the combine and how it's set up. So.
Great, thanks, Ty. We have another question from Laverne. He asks, when using the draper head, are you cutting high to minimize the amount of stalk and fiber passing through the rotor? How do you envision harvesting hemp grown for seed and floral that will likely have primary products of seed and flower near the top of the plant?
It'll be a tall cut. It'll be a high cut where, let's say you have 2 foot of flower material and seed at the top of the plant, and the plant's 6 foot high. You'll run the header, you know, below around 4 foot off the ground, 3 to 4 foot. So you'll be trying to minimize, and you'll be leaving a taller stem out in the field. Where like the bushy plants, you know, we're mowing it as close to the ground as we can. So that's definitely a different, you know, a different method. Yeah, we're just processing material with a stripper head this week, you know, running it through the machine and seeing what that does. And, you know, we're still learning. We don't know exactly where we're at as far as, and it's a very, very dry material, so it's a lot different than per se using a stripper head in a very wet crop that we're testing. But, you know, there's so much testing that we have to do yet. And a lot of the farmers are going to end up doing the testing and telling us, you know, how it went. So.
Yeah, definitely. All right, we have one more question. Another one from Laverne. Laverne, you're asking great questions, as always.
Mm-hmm.
He says, Ty, is the interceptor handling only the floral biomass and the fiber discharged on the ground?
Yes. Yes. What the interceptor sees generally is there will be pieces, you know, when I said a 1/4 inch pieces, there will also be some of the, like in a, well, pretty much any crop, there will be some of the outer branches of the stem that will be, yeah, the finer branches that maybe will be like 1 inch long. So, you know, there is some pieces, you know, and what we're also seeing with the material that we just are running through from a stripper head is the stripper head also takes off some pretty good sized branches. And we almost feel like the draper head will be better at processing, you know, sending less stems to the processor than the stripper head, because the stripper head is taking off branches too. And when it strips it into its components, it's a little harder to separate with the combine. But yeah, but you know, it looks like it's got possibilities for crops that, you know, are different that somebody wants to do. But we're kind of anticipating farmers wanting to go with different options. One of the things that we recently did was, at one time we had our power unit that we propel our system with. It mounted to the header. We have it adapted to the combine, so we can run any header on the machine now. So, you know, that's progress for us. So we're anticipating farmers to try lots of different stuff.
Yeah, definitely. And then we have one last question, and maybe this is a better one to have a conversation offline about, but I'll ask it anyway. It's from John. He asks, what is the cost of the Interceptor?
We're not, bashful about our cost. I mean, we're around $65,000 for our machine for depending on what option. When we get into some of the newer models, they have changed them a little bit to where it gets a little bit more expensive to make. But, we're trying to make a machine that farmers can afford. And that's, we've always been about trying to make a machine that, we can help a farmer that's not necessarily huge, but make a farmer that is, profitable, that is medium-sized. And that's kind of where we're at. And that does not include the wagon. The wagon that we're pulling is just we bought used, and we did a few refinements to make it work behind our machine. But, we're trying to make a cost-efficient machine. And we're going to only do a limited run this year. We're not planning on getting a bunch of these out there. And our window for making machines, it's closing, because we typically, we're working with the manufacturer. We're not actually building this ourselves. We're working with a company that already makes a lot of components for combines already in the industry. So they're making our parts, and we have a time frame where that takes place, lead time from when an order is placed to when the machine's actually ready to be put in the field. So, if a farmer orders something in September, they're obviously not going to be getting it in September yet. It will be after the harvest. So we're trying to address, the needs. And, quite frankly, this year, we're happy to work with a few farmers and do a good job and learn more and be better prepared for next year, because we know that, we can, at this point where we're at, we can only work with a few and do a really good job. But, we're happy to work with people that want to work with us. So.
Yeah, that's so important for sure, Ty. And then Joseph asks, will this machine be available in Florida?
We're working with, one thing I didn't mention, we're working with Platte Valley Equipment. It's an John Deere equipment dealer in Fremont, Nebraska, and they sell products nationwide. They just told me they had a service technician in California, and they spent a week there working with a farmer out there. So we're working with somebody that can transport equipment, and they obviously can sell, service, and support combines. And our technology revolves around the tech of a combine. If the combine quits, our equipment does no good. So it's been a huge, having access to combines and, having somebody that's willing to work with us has been huge. So when we actually sell machinery and service machinery, largely, in the future, although we see ourselves kind of working with farmers one-on-one this year, eventually Platte Valley will kind of take the helm of that with their sales and service department. And we will be more in the development side and keeping with progress. And we'll let them tackle, and work with the farmers. And we're all learning. We're trying to teach them. We're learning too. So it's hard to teach somebody when you're learning yourself. But, they're willing to take this on, and they've been a great asset. They've been a big help. And they're part of a dealer network that has about, I think they own over 30 John Deere dealerships. So I believe the John Deere dealer we're working with, from my understanding, they are the largest John Deere dealership network in the world, from my understanding. So we have a lot of possibility to grow. We're not expecting to do everything here this first year. We need to grow with the industry. We don't want to get overwhelmed, and we want to make sure that when we work with the farmer, we can learn what we can, and we can help them get the job done that they need to. So Florida, yeah, we're ready to send it to Florida. We just got to figure out the details.
Yeah, exactly. I'm sure Florida's ready for you too. Well, thank you, Ty and Beth and Matthew, for joining us today. We are going to wrap it up here, just because it's already 4:05. So this was such a valuable presentation and discussion around something that proved difficult for so many last year. So thank you guys. Thank you to our attendees for some excellent questions today as well. And I will provide Beth and Ty's contact info in tomorrow's follow-up email that you'll receive. along with the recording of today's webinar. So feel free to share this presentation. Oh, good, and there's their contact info on that slide as well. So, feel free to contact them to keep the conversation going, or if you have any other questions, or share the YouTube link with anyone who needs to start thinking about harvesting. And then if you have any questions about drying, feel free to reach out to info@iecompanies.com. We can definitely get your questions answered there. And we have 2 webinars left in our series. So next week we will have the lovely folks from Rec and Branding on our webinar. You won't want to miss this one, especially if you are in the process or even just need to revamp or rethink about your brand's unique edge in this fast-paced market. So they're going to actually provide a lot of actionable tools that you can apply to your own brand. It's a really good one. Be sure to sign up. We hope to see you there. And any closing remarks from Matthew or Ty?
I thank you guys for inviting us to participate, and we look forward to IEC Thermo drying some of our products. So.
Yeah, thank you, Ty and Beth, for joining us, and have a happy 4th of July, everybody. Thanks, Jen.
Yeah, thanks guys. Stay safe, and we hope to see you next
Thank
week.
you.
Bye, Beth.
Thank you.
Bye.